which is perfect. We'd be wasting our time doing the easy ones. So let's have a look. Hold on one second. Let's have a look at 10.
All right, one second. I'm going to carry you with me and go grab my calculator.
Okay.
Sorry. Because I'm not going to be able to do that efficiently without my calculator. Okay. So, wouldn't you do 12 times 18 and then divide it by each of the answers and see what you get?
I suppose that would probably work. In other words, that'd be 180, 196. So you're suggesting we divide 196 by each of these and see which is divisible?
18 is 216.
What's that?
It's 216.
Oh, excuse me.
And when you divide by 36, you get 6.
And is that the only one that produces an integer?
Let me see. No.
So, that's meaningful. 30 goes into that, doesn't it?
No, 27.
27 goes into it.
As does 24, and therefore 8.
Yeah. Well, let's analyze this a little bit. Not sure exactly how to solve this algebraically, but we can certainly make progress. What is the first multiple of both 12 and 18?
Three.
Multiple, not factor.
Oh. 36.
Uh-huh. In other words, 36 is a multiple of 2 of 18 and a multiple of 3 of 12.
Gotcha.
Now, obviously I can't add 18 or 12 to that to get the next multiple. And in fact, it's fairly easy to see that the next multiple has to be 72. In other words, it would either have to be 36 plus 18, which isn't divisible by 12, or it'd have to be 36 plus 12, which isn't divisible by 18. Which tells us that the next multiple is going to be 72, and then 108, so forth and so on. And now we can see that each of those multiples has a factor of 36. And not 27, not 24. In fact, when you find the first multiple, 36, you can kind of rule out 8, 24, 27, and 30.
Yeah.
Because it has to be divisible into 36, and the only one is 36. Hold on. I didn't realize that I had not gone through and erased my tick mark on the... So, let me think for a moment. Let's solve this without multiple choice. since the multiple choice doesn't really do any good on this particular problem. In fact, I can show the answers, and you can figure out how you get that. It is kind of useful to see what the answers look like. They're all base 2 to some power. So that does give you a lot of clues as to how to solve it.
Well, 2 to the 2x is 4.
The secret is to find the common exponential base and write these numbers in that base. In other words, I'm going to write 4 as 2 squared in parentheses, and then I'm going to take it to the x power.
Okay.
I'm going to write 8, 2 cubed, and I'm going to take it to the x power.
Gotcha.
Now we have 2 to the 2x times 2 to the 3x equals 2 to the 5x. Add the exponents. Hold on. I feel like I have MS today. I can't accurately move my... The average of 6 numbers is 6. If 3 is subtracted from each of 4 of the numbers, what is the new average?
So if you just start with 6, so then you'd have 3 6s and 3 3s. Oh, you'd have 2 6s and 4 3s.
Okay.
Divided by 6.
So you're saying start with 6 sixes.
Yeah.
I like that idea. That's clever. And then if 3 is subtracted from 4 of them, then you'd have this.
And that adds up to 24 divided by 6 is 4.
Good. Keep hitting the wrong key here.
Ew. I don't like that one.
Well, let's draw it. I guess I'm going to need to draw the XY axis first. Minus 1, 1. 5, comma 1. Okay, well, at least it's parallel to the x-axis.
So that's 6.
And 2, comma 5. So this actually is going to be quite easy because it's parallel to the x-axis.
Uh-huh. So that bottom one is going to be 6.
Excuse me just a second. This one is 5, comma 1. Okay.
Oh, and it's going to be an isosceles triangle.
Not pertinent. What's the area of it? What's the, oh, excuse me, my mistake. I thought they were asking for the area of the triangle. It's really easy.
It's not actually. So, I lied. No, it is. It is.
It is isosceles, isn't it?
It isn't. I think I lied again.
Uh-huh. Yeah, it definitely is. It's halfway. First of all, it's halfway between 6. It's 3 from there and 3 from there. So that will make it simpler. So we know the length of this side. Can we figure out the length of this side here?
Yeah, you can use the square root of y minus y0 squared.
The distance formula, which is basically the Pythagorean theorem.
Mm-hmm.
We're looking for the hypotenuse. So what is it?
-4 squared. And then 3 squared, so 9.
Notice that that is a 3, 4, 5 triangle.
Mm-hmm.
So that is 5, that is 5, the bottom is 6. That should be the answer. Okay. How many positive two-digit integers are there such that the tens digit is greater than 5 and the units digit is odd?
I don't like that. I don't like that at all. So
How many tens digits might we have?
9.
No, it's got to be greater than 5. So it could be 6, 7, 8, or 9.
Gotcha.
And it's got to be odd, which is 1, 3, 5, 7, or 9.
So it's 5 times 4, so it's 20.
Uh-huh.
Not too bad.
No.
I don't even know how to start that one.
Okay, this is a perfect example of what I've been talking about, where you have variables in the stem, and your answer is nothing but a combination of those variables. So, in other words, we can pick numbers, figure out what the answer is, and then figure out which of those 5 answers matches the number we know. Pick some simple numbers for A and B.
2 and 4.
So what is 2% of 4% of 200? Now I'll go back and pick some simpler numbers that are going to make this easier.
1 and 1.
Well, I was going to say 2 and 5.
Okay.
Just because that'll make 10. It's going to make the math easier. So 2% of 5%. In fact, let's make the math much easier and let A equal 10 and B equal 50. Because I'm going to get confused with my decimal point here if I have too small a numbers. We know what 10% of 50% of 200 is. What is it?
I don't know.
What's 50% of 200?
50.
What's
100. 100.
Okay, and what's 10% of 100?
10.
So we know the answer has to be 10 when A is 10 and B is 50. Let's start checking. Is 500 divided by 100 10? No. Is 500 divided by 50 10? Yes. Is 10 times 50 10? No. Is that 10? No. And that's not 10 either. So you see what we did was we picked numbers that made it easy for us to come up with an answer. And then we merely found which of the 5 answers is equal to that number based on the numbers we picked.
That makes sense.
I find that particularly useful on these problems because I have a hard time wrapping my head around which of these. You got multiplication going on, you got division going on, you got all kinds of stuff. And it's difficult for me to figure out what this should be, but when you stick numbers in there, there's no denying it. It has to work for whatever numbers you pick because they didn't tell us what A and B had to be. So I can absolutely make A and B anything I want.
Okay. But there has to be variables in the answers to do that, right?
Well, I'm not sure it has to be, but yeah, usually that's the sign I look for. Especially if you have variables in the stem that aren't defined, they're not specified, and you have variables in the answers. That is the perfect spot. Picking numbers will always work. Now, the worst thing that can happen is you can accidentally pick some numbers that will give you 2 answers that both were 10. Okay? When that happens, go back and merely change your 2 numbers you picked and isolate it between the 2 answers you got that were the same with the first set of numbers you picked. And that has happened to me before, where I've picked some numbers and I found 2 answers that both were this number. Well, I just went back, picked 2 different numbers, and that decided it for me. I don't know. There's something wrong with this problem. If you don't mind, let's skip it. I've looked at this problem many times, and I can't figure out whether it's a typo or I'm just an idiot. Because I can't understand it. And so let's not spend our time. I mean, I kind of hate to do that, but if it really is a typo, it would be a total waste of time to try to figure it out.
So A has to equal 40, so B has to equal 40. Right?
So how'd you get A has to be 40?
Because if B plus C equals 140, there's only another 40 degrees left over.
Oh, so A has to be 40. I got you. Okay, all right.
So B has to be 40.
You're way ahead of me sometimes. Of course, that's because sometimes I'm still centering the picture trying to... You've already solved it. Okay.
I like problems like that.
Uh-huh. No, you're good at the geometry for sure. This is kind of
But I'm not very good at pre-algebra.
Okay, number 18. First time I ever encountered this problem, I had problems with it.
It's -4.
And you got that how?
Because, so 9 to, it's a line, so 9 to 0 is 3 times 3, whereas 0 to negative 6 is only 2 times negative 6. So then you divide 6 by 3, and then you multiply that by 2.
So basically what you did was figured out the slope, which was 3 over 2.
Mm-hmm.
And it has to be the same slope from there to there.
It's just a ratio.
Exactly. And that's 3 over 2 also. Very good. First time I looked at this, because they didn't label the origin with a point and put 0, 0 there, I didn't think they'll do the problem that way. But boy, you did it immediately that way. It's good.
Ooh, so this is going to be pi problem. So first we have to do 60 squared times pi. And then we have to do 100 squared times pi. And then we do that minus 60 squared. There. And I get about 20,000.
Yeah. Good.
Ooh, it's circled. Is it special?
It is.
Uh-oh.
I used to have notation on these where a circle meant, now I think the circle here merely means it's the highest level of difficulty.
Oh boy.
I used to make notations on these saying there's a shortcut to do this. But those were dots. I'd have a dot if there was a shortcut, and then I'd have 2 dots if there was a really good shortcut or something like that.
Gotcha.
What do you notice first off about this problem?
It's all variables.
In the stem and the answers. And they don't say what any of the variables have to be. Therefore, if you have any doubts whatsoever, you may have a brain that can translate these words into this formula. I'm not good when there's lots of multiplication and division going on. I get confused pretty easily when there's a bunch of stuff going on. But the one way I know for certain how to figure it out is to make up numbers for P, W, and X such that I'll be able to figure out how many hours it'll take them to finish the paper.
I think it's C.
You think it's C?
Yeah.
Okay. Let's try C. Make up some numbers for P, W, and X.
235.
P equal 2, W equal 3, X equal 5. So if we have 2 pages long, 3 words per page, that's 6 words. Bill types an average of 5 words per minute. How many hours will it take him? Well, there's 6 words. He's going to type 5 words per minute. It's going to take him about, let's change our numbers so that we have easier numbers to work with. Let's make our numbers 6. Let's make X 6.
Okay.
Now we know that he can type 6 words per minute. There's 6 words, so it's going to take him 1 minute per page. No, it's going to take him 1 minute based on the numbers we picked, right? If you had 2 pages and there were only 3 words per page, that would be 6 words. And we've said he can type 6 words per minute, so it'll take him 1 minute or 1/160th of an hour. So there's the answer we're looking for, is 1/60, based on our numbers.
Okay, so it's not C.
Well, A works. Notice A is 6/60 times 6, that's 1/60.
Got it.
B does not work. C does not work. D, we kind of have to check all of them because you can never tell if you just accidentally have picked wrong numbers. D doesn't work and E doesn't work. So the only answer that gives you 1/60 is A. Okay. Well, these are grid.
Oh, so 150 times 12 is 18, so 18 minus 1250 is 5.5 divided by 12. It's about 46 cents.
Now the question is it how much money are you saving on a dozen ride tickets or per ticket?
Oh, so it's 5.5. Never
Well,
mind.
I don't know. I'm having to reread it to find out. How much money can be saved by buying a dozen tickets at once rather than buying each ticket separately? Yeah, I would say 550 is the answer.
Okay.
I don't know how this problem got on here. You'll notice it's
Okay,
question
so
10. There must be one problem on this page that's high degree of difficulty. It's probably 18.
no, the area is 49.
Huh?
It's 49.
Okay.
I hope they give me problems like that on the test.
Well, you'll get some for sure, but we haven't been focusing on easy problems at all.
So we have T in both, so do we want to try to find T?
Well, notice they're asking about RS. If we could change this T into an S, or a function of S, we probably can solve for RS direct.
Okay, so how would we do that?
Well, let's work with this to make T a function of S. So first of all, if I add 4 to both sides, multiply both by 9, by T, and divide both sides by 9, there I have T as a function of S. Now, substitute into the lower equation and solve for RS.
Okay, so subtract 2.
Yeah, that's for starters. So that's equal, I lost my pen. So let's see, so that's equal to 4. And then we have 5RS over 9 equals 4. 5RS equals 36. RS equals 36 divided by 5. And you would want to put it in as an improper fraction. The only way you do not want to grid that is 7 1/5.
Yeah,
You would not get credit for that. You would get credit if it was a decimal, 7.2, or 36/5.
Okay. Oh, so we need a prime and prime number between 20 and 40. So 37?
Where'd you come up with 37?
Is that a prime number?
It is?
It was a guess.
But what is n if 37 is the number? N wouldn't work.
No. All right.
So let's try starting by listing the prime numbers between 20 and 40.
Oh, it would work if it was 29.
Because then n could be...
N could be 12. I mean,
It's
not
not going
12.
to be 29.
8.
If n was 8, then it would work. Because then you would have 29. Exactly. So n does work. So your technique actually was faster than my technique, because my technique would have required listing all the prime numbers between 21 and 30, or between 20 and 40, and then finding one that was perfectly divisible by that, where n would be an integer. But I kind of liked your technique better. Just picking and guessing, pretty much. Well, no, you found some prime numbers and see if you could make an integer. Although that's going to be just as fast as mine, because I was going to do the same thing. It's just I was going to list all the prime numbers, which isn't necessary. If you can find a prime immediately and realize that with n being an integer, that you can make that prime number out of 3n plus 5. So, all right, 13.
$24.
I don't think so. The ratio of girls to boys is 3 to 4. What is the ratio of girls to students?
Oh, so there has to be 7.
Has to be a multiple of 7.
So it could be 21 or 28.
Right, so it could be 21 or 28. In other words, you would have 9 girls to 12 boys, or you would have 12 girls to 16 boys.
Mm-hmm.
The key, and you'll see this in a number of problems, is this 3 to 4 has to be expressed as 3 to total. If they're asking about total, you have to make that translation at some point in time. If they're asking about total number of boys, then you would make it 3 to 4 and work with that. But when they ask about total students, we want to make sure we don't write 3 to 4, but 3 to 7.
Okay. She can fit 80.
Okay, here's the box. How many can she fit in this bottom space?
She can fit exactly 20.
Good. 80 is correct.
It's going to be half, so 15. No, it's going to be a third of it. A third of it.
If I have similar circles, this radius is twice this radius. What is this area compared to this area?
8 times is what?
4 times.
4 times, sorry.
Because this would be 4 pi, and that would be 16 pi, so it's 4 times as big. In other words, when you go from a linear dimension to an area dimension, you have to square the radius relationship. What started out as a 2-to-1 relationship becomes a 4-to-1 relationship when you go to area. No matter what the figure is, if I have a square of side 2 and a square of side 6, 3 times this area is 9 times this area. It's the square of the linear relationship. Same thing with similar triangles, because you get the area of a similar triangle by multiplying base times height. What they're saying is this dimension is half of that dimension down there. They're also saying this height is half of that height. So by the time I take this base times this height relative to this base times this height, it's 4 times. So the area of the smaller triangle has to be 1/4. Because its base is 1/2 this base, and its height is 1/2 this height.
Gotcha.
All right. And likewise, when you go from 2 dimensions to 3 dimensions, it's the cube. In other words, if I take that square and I make it the side of 6, the area went from 4 to 36. But then if I go to a cube of 6, the volume of this cube is 3 cubed, 27 times the volume of this cube. Notice the volume of this cube is 8. The volume of this cube is 216. even though each side of this cube is merely 3 times the side of this. In other words, when you go from linear to square, you square the relationship. When you go from linear to cube, you cube that ratio. So what became a 3-to-1 ratio now becomes a 27-to-1 ratio by the time you're comparing volume. X is an integer between 3 and 400 that is divisible by both 3, 6, and 9. What is a possible value of X? Well, how hard could it be to find a number between 300 and 400 that's divisible by all those things?
Guess and check.
Well, right offhand, six isn't divisible into that. I know 9 is divisible into that. 6 is not. So, what if we multiply 18 by 9, 162, and double it? 324 has to be divisible by 3, 6, and 9.
Yep.
In other words, I multiplied 3 by 6 by 9. That gave me a common denominator of 162. So all multiples of 162 have to also be divisible by 3, 6, and 9. Three quarters, 4 dimes, 2 nickels, and 6 pennies. She takes a coin out. What's the probability that it's worth more than 5 cents?
It's going to be 7/15.
Yeah, what is that problem doing on there? Okay. What's it doing in my hard section? That's a hard one for sure, I think. Let's see. So the first one, the radius is equal to 2. The second circle, the radius is equal to 4. The circles intersect at 2 points. What is a possible distance from the center of one circle to the center of another?
Could be 2.
Could be 2?
I mean, it has to be larger than 2.
Yeah, it has to be larger than 2. If I take a calculus approach here and say, well, I'm going to make my 2 circles look like this. Now, granted, they're not intersecting at 2 points, but what is the distance between here and here?
6.
Okay, so all I have to move is this circle a fraction to the left.
So it has to be greater than 2 and less than 6.
Anything, yes, has to be greater than 2 and less than 6.
So you could just say 3 or 4.
Yes, you could. Yes, you could.
That's not bad.
No, it's not bad at all. Let's see, this is 573. That's interesting. What is the y-intercept of the line that passes through those 2 points? Okay, this can't be hard.
Oh. I see. So what's 21 divided by 7? So it's going to be 14.
So what's the rest of your steps? How'd you get that?
So I did
Did you use point slope, or did you use y equal mx plus b?
I don't really know.
So
I
what'd you
just
do?
did 1 to 4 is 3. And
Okay.
since 27 to 41 is just 2, I don't know. I just divided 21.
By 3. That definitely gives you the slope. Rise over run is 7.
Yeah. So
But
I
then
got,
how do you get a y-intercept of 14?
so since it goes down by 7 each point, 1 to 0 is...
Oh, very good. Very good. So it's got to go down by 7 from going from 1 to 21 down to 0, comma k.
Yeah.
Very good. That's the fast way to do it, for sure. Let me put a tick mark right by this problem, because I would have done it the slow way. In other words, I would have used point slope formula, which is y minus 21 equals the slope times x minus 1, and then put this in y equal mx plus b format. So it's 7x minus 7 plus 21, or 7x plus 14. There's your intercept. I liked your way better. It's quicker, more intuitive.
Is that x to the negative? Oh, yeah. Okay.
That's why I wrote it.
Thank you.
These Kaplan books, a lot of times you can't see their negative signs. And if it's a fraction, they'll put their negative sign on the same level as the fraction bar, and you really can't see it. They're terrible, right? I don't know why I keep buying them. Well, actually, I got this a long time ago. But so f of 3 is going to be what?
So I got approximately 5.233, and then I would just go through and guess and check on which one of those equals.
Wow. Okay. I can't argue with that method. I hate it, but so in other words, we're trying to solve this, right?
Yeah.
Well, this isn't bad. That's 1 over 27. Plus, this is the square root of 27.
Which is equal to 3 square root of 3.
Not sure. Let's see. If I had to find a common denominator, then this would be 27 over 27. And I would get 1 plus 81 root 3 over 27. C. Which method is faster? I don't know. Maybe yours, but maybe not. Depends on how fast you can narrow down those answers to give you your calculator answer. I think it's probably worth you knowing how to do this algebra. Did you see what I did on the algebra? Okay. Although I have to admit, you're not going to find much that's harder algebra than that.
That's A.
Okay.
Because if S is greater than R by X, then it's going to just be R plus X.
So you're saying S is equal to R plus X, and T is equal to S plus X.
Yep. So it's
So
just
the average of R, S, and T would be the average of R plus X plus R plus 2X, which is 3R plus 3X divided by 3, which is R plus X. You're way ahead of me, Em.
Well, you could just say that since there's an equal distance between R and T, between R and S and T, then S is going to be the average, so R plus X is equal to S.
Yes, you could. Good. Hold on. Am I missing something here? Yes. Would have been hard without that top line.
It's A.
Not A. Solve that. Find a common denominator.
Oh, I lied. I'm sorry. It's B.
C?
B.
Okay. Solve this, finding a common denominator. In other words, how many thirds is 4? It's 12 thirds. So now the problem becomes x minus 6 plus 12 over 3, or x plus 6 over 3. D. There's an upside and a downside to your intuitiveness. I'm serious. It lets you get the correct answer on a lot of these that I would have to take longer because I'd have to go through the math. And you see it right away. The problem is there's other problems where you see it right away and you go with it and you don't have it right. I'm not sure you wouldn't be better off by working through the math, at least if you have time. It's all a game of speed, so I don't know, maybe go through it the fast way, and then if you have 20 minutes left at the end of the test, go back and check the ones that you think maybe you did too hasty or something.
Okay.
I mean, that's all I would suggest as a strategy.
Yeah, for sure.
Which is the least positive integer a, for which 25a is the cube of an integer.
$125. No, I don't know.
Well, so let's back solve. This is, if there was ever a problem that was meant for back solving, it's this, for a couple of reasons. They say least, so we're not going to start at 125, we're going to start at 1. So is 25 the cube of an integer? No. Is 75 the cube of an integer? No. Is 125 the cube of an integer?
Yes.
That's it. We don't have to check any higher. This is one of those where when you're back solving it, you definitely want to pay attention to whether they're asking for least or greatest. If they said greatest, we'd start at 125 and work our way down. All right. Let's do one more here. The sum of three numbers is 27. Is this a joke?
That's 9.
Yeah, I know. It almost seems like a trick question, huh?
Yeah.
Well, let's do one more then. 12. I know this one's not that easy.
So, 16. The radius is 8. So,
Hold on. How'd you get that?
because, oh, never mind. I lied. I'm sorry. If the area
Sometimes you're so far ahead of me that I have to ask where you're getting these because I don't have a clue as to where you would get that from.
I was way ahead of myself, actually. I read that if the area of the rectangle is 32, I thought it said that the side of the rectangle is 32.
Okay, so what are we going to do with the information the area is equal to 32?
I was going to use 6 and 8. I mean, not 6, 4 and 8.
4 and 8. That does work, doesn't it?
Yeah, so
In
why
other words,
would
you did it right away. See, I would have done it the hard way. I would have multiplied y times y plus 4, let it equal to 32, solve that quadratic to get y equals 4 is one solution for sure.
So the answer is going to be 4 pi.
Uh-huh. Okay, good. Be careful on be careful on being too quick on questions like this, merely because it's really easy to be off by a factor of 2 on these kind of problems. Because you calculated the diameter, and then we have to take half that, and then we have to square that, and we're only talking about one circle, not 2. So I would say add an extra level of meticulousness to problems like this, because you would hate to get this wrong by being off by a factor of 2 just because you did it too quick.
Yeah.
All right. I'll mark that spot, number 12 on this page. Now, are we meeting Sunday?
Yes, we are.
Okay.
And then next week I will be gone for both sessions.
Okay, so Sunday will be our last session until the 4th of April.
Yes.
Okay, I was a little confused when we talked last time. I was thinking this was the last session. So I'll see you Sunday at
4:30.
4:30.
Awesome. Thank you very much.
All right, and we'll still be on Chapter 9? We won't be on Chapter 10?
Yes.
Okay. Talk to you Sunday.
Sounds good.
Bye-bye.
Thank you. Bye.